Two friends sit down on a slow afternoon with a single coin. Heads, one of them wins a point. Tails, the other wins a point. That's it. The fairest game ever invented. Nothing up anyone's sleeve. They flip it a couple hundred times just to pass the time. And here's the thing nobody can shake afterward. For almost the entire afternoon, one of them was winning. Not winning at the end, winning the whole way through. The other players spent hours behind, clawing, never once pulling ahead. And they swear the coin was fair, because it was. So they do the natural thing. They blame each other. They blame the coin. They are sure something was rigged. Nothing was rigged. What happened to them is a law of mathematics. One so sneaky it has fooled gamblers, statisticians, and probably you. Stick around, and you'll never watch a fair game the same way again. Let's give them names that match the coin. We'll call the two players heads and tails. The rules could not be simpler. We flip a fair coin. Comes up heads, the heads player gets a point. Comes up tails, tails gets a point. 50-50. No skill, no strategy, no memory. Just the coin. To see who's winning, we track one number, the score gap between them. Start them dead even, right on the center line. Every heads nudges the line up, heads pulls ahead. Every tails nudges it down, tails pulls ahead. When the line is above center, heads is in the lead. When it's below center, tails is in the lead. And when it touches the center line exactly, they're tied, neck and neck. That wandering line is the whole story of the game. Let's watch it move. So the question that runs the whole video is simple to state. As this line wanders up and down over a long game, how much of the time is it spinning above the center versus below? Above means heads is leading. Below means tails is leading. We're not asking who wins the last flip. We're asking who's been ahead for what slice of the whole game. Think of it as, what fraction of the afternoon did heads spend in the lead? If that fraction is big, heads dominated. If it's tiny, poor heads was behind almost the whole time. And if it's right around half, well, that would mean they traded the lead back and forth fair and square. That fraction is the one number we're hunting today. Okay, here's where you get to guess, and I really want you to commit. We're going to play one long, perfectly fair game. Hundreds of flips. Then we measure what fraction of the time was heads in the lead. Now, we don't play it once. We play thousands of these games. Each game gives us one fraction. Some games heads leads a lot, some a little. If you collected all those fractions and made a histogram, what shape would it be? Where would the pile of games be tallest? Most people feel this one instantly. It's a fair coin, so the lead should seesaw, heads ahead for a while, then tails back and forth. So surely most games land near the middle, each player in the lead about half the time. A nice hump in the center, right? Lock in your guess. Picture the shape of that histogram. Then keep watching, because the real shape is going to feel illegal. Before we run the games, let's build the intuition, because it's the key to everything. Forget fractions for a second. I just want to ask, how often does the game return to a tie? A tie means the line touches the center again. They're dead even. Feels like it should happen all the time, right? Fair coin. The lead should keep crossing zero. But watch what actually happens to that line. Say heads gets a little lucky early and the line drifts up, a small lead. To get back to a tie, the line has to walk all the way back down to center. And a random walk doesn't aim for anything. It has no memory, no gravity pulling it home. The farther it has wandered from center, the longer and luckier the trip back has to be. So ties don't happen constantly. They're surprisingly rare. And the bigger the lead grows, the rarer a return to even becomes. Here's the consequence, and it's the heart of the whole thing. Because returns to a tie are rare, the lead doesn't flicker. It commits. Once the line drifts to one side, it tends to stay on that side for a long, long stretch. It's not bouncing politely around the center. It's wandering off and setting up camp. Think about what that means for our fraction. If the walk crosses center only a handful of times in a whole game, then it spends each game mostly on one side. One long reign, maybe two. Not a tidy back and forth, a dominant stretch. So whoever happens to pull ahead early often just stays ahead. For ages. Not because they're better. The coin is perfectly fair. But because climbing back to even is harder than it feels. The lead is sticky. Pull that phrase. Now let's prove it by playing. Let's make this concrete with a single game. 200 flips. Watch the line. Heads jumps ahead early, and look, it just keeps the lead. Tails fights, gets close to even a couple of times, but never crosses over. The line lingers above center almost the entire game. Now we measure the fraction we care about, time heads spent in the lead. In this game, heads was ahead more than 90% of the time. 90% from a 50-50 coin. That's exactly the afternoon our two friends had. One player camped on top. Now, is this one game a fluke? Maybe we just got a weird one. There's only one way to find out. Play it thousands of times and tally every fraction. So we let a computer hammer it out, game after game after game. Each game, 200 fair flips, measure heads time in the lead, drop one dot on the histogram. 100 games, 1,000, then 200,000 games. And the pile that forms is not the gentle hump you guessed. Watch where the games stack up. They pile high against the left edge, games where heads led almost none of the time. And they pile just as high against the right edge, games where heads led almost all of it. The middle, the each one ahead about half the time, outcome you expected. That's where the histogram is lowest, the valley, the rarest result. It's not a hump, it's AU. The shape sags in the middle and shoots up at both ends. The most likely games are the lopsided ones. A near-even split is the exception. That U-shape isn't random noise. It's a precise, famous curve. Mathematicians call it the arcsine distribution, and it nails our histogram exactly. Lay the smooth curve over the bars and it drops right into place. This is Levy's arcsine law, a genuine theorem over a century old. And it says, flatly, in a long fair game, the extreme splits are the likely ones, and the even split is the rare one. The single most probable thing that can happen is for one player to be in the lead for nearly the entire game. A fair coin, and yet domination is the default. Let me give you the actual numbers because they're wild. We ran 200,000 of these games. Here's what came back. In about 1 in 5 games, one player led 10% of the time or less, barely ahead, ever. And in about another 1 in 5, that same player led 90% of the time or more. Put those together, in roughly 40% of all games. One player is in the lead for 90% of the entire game or more. 40%. Domination is nearly a coin flip away from being the norm. Now, the split we all expected, each player ahead between 40 and 60% of the time, that happens in only about 13% of games. And a really even game, ahead between 45 and 55% of the time, just 6%, the rarest band on the whole chart. And those lead changes? Across 200 flips, on average only about 5. 5. The lead barely flips. It's sticky, exactly like we said. So why does this blindside everyone every time? Because we expect fair to mean balanced moment to moment. It doesn't. Fair only promises that over infinity, heads and tails come up equally often. It promises nothing about the journey, and the journey is wildly lopsided. Our intuition pictures the lead politely oscillating around even. But a random walk doesn't oscillate around home. It wanders, and getting back to even is rare and slow. So the lead commits. One player reigns. The other chases all afternoon. No cheating required. Just a fair coin and a long enough game. That's the trap our two friends fell into. The game was fair. Their expectation of what fair should look like was the lie. Once you see the arcsign law, you start spotting it everywhere. It's why a perfectly fair contest can feel rigged. Why one team in a league of equal talent seems to dominate a whole season. Why your losing streak felt like it would never, ever end. And why, when you're winning, it feels like you can't lose. Sticky leads both directions. It's not always destiny or momentum or a hot hand. Sometimes it's just a fair coin doing the most ordinary, lopsided thing in the world. Here's a bonus one to chew on, down in the comments. The arcsign law has a sequel. Take the last moment the game was ever tied. The final time the score touched, even before drifting off for good. That last tie follows the very same U-shape. It almost always happens either near the very start of the game or near the very end. Almost never in the middle. Ties cluster at the edges of time itself. Tell me below, where have you felt a sticky lead, a winning or losing streak that just wouldn't break? I'll see you in the next one.